Alright, we're up to question 30, okay? We're near the end, not quite there yet, but give us some time and let's do it together. Okay, express cosine times secant minus cosine and express this in terms of sine, right? So let's do that. Well, first you need to know that secant, same as 1 over cosine, right? That's another way of writing it. And we'll leave cosine as cosine over here. Alright, so I'm just rewriting secant as 1 over cosine. And now we're going to use the distribute property to actually multiply it out. So cosine times 1 over cosine, well, that's cosine over cosine, right? Minus cosine times cosine, well, that's cosine squared, right? And now let's see what happens. Well, cosine over cosine, or any number over itself, or any variable, anything over itself, is equivalent to 1. So that's 1 minus cosine squared. Okay? And from here, you can actually change this using the Pythagorean identity. We know that sine squared plus cosine squared is equivalent to 1. So let's take a look over here. Let's say I'm just going to move cosine to the other side. So I do this by subtracting, and what you get is sine squared equals 1 minus cosine over here, right? And notice that 1 minus cosine is the same as 1 minus cosine from this example. So what is 1 minus cosine equivalent to in terms of sine? That's equal to sine squared over here. And that is your answer, right? We express the entire problem over here, multiplication, that expression, right? We simplify the expression and we express it in terms of sine. That's equivalent to sine squared. Alright, question 31. A cup of soup is left on a countertop to cool. The table below gives the temperature in degrees Fahrenheit of the soup recorded over a 10-minute period, right? So pretty much, you have a hot cup of soup, right? It's really, really hot, right? So the starting temperature is going to be, extremely hot, right? 180 degrees Fahrenheit. And over time, over 2 minutes, it gets a little lower to 165. Right, 4 minutes even lower, and after 10 minutes it goes down to 110 degrees, right? So it makes sense, right? Over time, if you leave it in the room, temperature is going to slowly cool down and eventually go down to room temperature. Okay, so the question is to write an exponential regression equation for the data, right, and rounding your answer or values to the nearest thousandths. Okay, so this you're going to use your graphing calculator for. So I'm going to take out my graphing calculator, and you're going to have to enter the information here. So let me tell you where to go. You're going to have to click on the statistics key, stat over here, click on that, and the first one, click on edit. So press enter. L1 is line 1, which we're going to put down the information of everything in minutes. So that's the first row over here, 0, 2, 4, 6, 8, 10. That's 0, 2, 4, 6, 8, 10. And line 2, you're going to put in all the data in terms of temperature. 180.2, right? 165.8, right? And let me fast forward this a little bit. Right, and there you have it. All the data is inputted into the calculator. Again, I press stat and edit for this information. Now that we have all the information here, we can click on stat again. We can go to calculate, right? And we're going to go down to where it says exponential regression. Over here, so EXP, REG, that's exponential regression. We click enter there. And now we have to tell the calculator where to get the information from. So remember we used line 1 and line 2 before. So now we're just going to use, press the second key, and then press the number 1 for L1, line 1. Press the comma over here. and now press second and 2, you get line 2. Right, so that's telling the calculator to get the information from line 1 and line 2, and that's where we input our data. Click enter over here. Right, and we have the exponential regression. It tells you that the formula should be y equals a times b raised to the x power. Well, what is a? Well, a is 180.3768, and b, right, b is 0.95386. Right, so I'm going to take that information and I'm going to write it down on the right side. Right, again, the formula is y equals a times b to the x power, right? And the calculator tells us that a is 180.376. It says rounded to nearest thousandth. So before it was 68. So instead, I'm going to round the 6 up, right? Which will give us 377, right? And B was 0.95538, so I'm around that to 4, right? And that's to the x power. And there you have it. That's our exponential regression equation for the data that's given. Okay, question 32. This question is actually pretty quick to solve, right? As long as you remember how to change radian measures, or find radian measures of degrees, right? So we have 216 degrees. To convert this into radian measure, you're going to have to multiply this by pi over 180. Okay. And there you have it, 216 pi over 180. Right, and they want to express this in nearest tenth, so just use your calculator, right, for this. And I'm going to have to input in the calculator 216 pi, so that's second, right, and this exponent is pi, divided by 180. Okay. Now, before we press enter, since we're using pi in that calculation, the calculator needs to know the value of pi, so make sure, I will go to mode and make sure it's under radians. If it's not under radians, you might get a different answer, but whenever you use pi in calculating, make sure it's on radians. Okay. So over here, press enter. You got 3.76. I believe it says round to nearest tenth, so that's 3.8. Right, so this is 3.8. That's the answer. Okay, question 33 is find the third term in the recursive sequence over here. Alright, so let's take a look at what we know. We know that A1 is equal to 3. Alright, so A1, let me get this pen going. A1, oops, whoa. Okay, so A1 is equal to 3. We know the formula to get the next one is described over here, AK plus 1, right? And let's say I want to find A2. Well, to get A2, that's A, right, K plus 1. If I want to find A2, K must be 1. That's the same as A1 plus 1, right? To get A2 is the same as 1 plus 1. Now, so I'm substituting 1 for K to find A2. Right? This is A2, by the way. Okay, but just remember this one is K, and according to the formula is 2A, right? 2A, K. In this case, it's 1. So I'll click 1 over here. Minus 1. Right? So those are the key numbers I'm plugging in. Is 1 over here. Now, so A2 is equal to 2 times A1. Well, A1 is the previous number, which you know is 3. So it's 2 times 3 minus 1. That's equal to A2. So A2 is equal to 6 minus 1. So that's equal to 5. Right, so A2 is 5. Okay. So we need to find A3. So we're going to do the same thing. To find A3, right, so far it's question mark. But when you use the formula again, right, so A3, well, that's equivalent to A, K plus 1. In this case, I want 3, so K must be 2, right? So it's A2 plus 1. Right, remember this 2. And now when we use the formula, it's 2A, that's K, in this case is 2, minus 1. So now we see that I want to plug in a number for A2. Well, A2 we know is 5 from the previous, so that's 2 times 5 minus 1. It's equivalent to 10, right? So A3 is 10. A3 is 10. And that is the answer. Okay. Also the keyword recursive. Recursive just means usually requires the previous term, the previous number in the previous term to solve the next one. Okay, question 34. Alright, the two sides and the included angle of a parallelogram is 18, 22, and 60. Right, so let's draw a parallelogram. Okay, not the best drawer here, but there you go. That's parallelogram. One side is 18, the other one is 22, and we know in between the included side is 60 degrees. Right, find the exact area in simplest form. Okay, so let's try and find the area. Right, so we don't have the area or formula to get the area of the parallelogram, but we do know how to find the area of a triangle. So I'm going to split this parallelogram in half over here by drawing this diagonal, right? And we can sort of find the area of this triangle over here, right? Using the area formula from the reference sheet, and the area formula is equal to 1/2, right? AB sine C. Right, so AB is just the two sides, sandwiching the angle, right? So A is 18, B can be 22, and vice versa, times 1/2. Right, sine C is the angle in between, so that's sine 60 degrees. So we got 1/2 of 18, that's 9 times 22, and 9 times 22 is equivalent to 198. Alright, sine 60. Sine of 60, the exact value of that is radical 3/2. Most of you guys should try to memorize that. That's 198 times radical 3/2. That's going to be 99 radical 3. Okay, so this is the area of one triangle. So this is the area of, let's say, this red triangle over here, right? So we want to find the area of the entire parallelogram. Well, there's two triangles here, and because I split diagonal right in the middle, right, both triangles are exactly the same. They're exactly equivalent to each other. So I want to find the area of both. I'm just going to multiply this 99 radical 3 times 2, right? So the area of the entire parallelogram will be 198 radical 3. Right? And that is the area of the parallelogram. Alright, I'm going to pause over here. Thank you guys for watching. Like and subscribe and comment below. If you have any questions, view the next video for the other answers to question 35 onwards. Okay, thanks for watching.